Hello and welcome to today's web seminar, Maximizing Test Coverage at Every Stage of Your CICD Pipeline with Visual AI, sponsored by Applitools featuring Brandon Murray. I'm Harry Gagnon and I will be the technical support for today's webinar. Before the presentation begins, let me explain this console. The panel on the right has a feature to chat, ask questions in the Q&A tab, and download handouts. If you minimize this panel, just click on the blue chat button to reopen it. If there's a download of today's slides, as well as other useful handouts in the Handouts tab. The polls will also be located in the chat panel. If you experience any technical issues, please send me a private chat and I'll be happy to help. This event is being recorded and will be made available to watch on demand. Once the recording is ready, you'll get an email with instructions about how to access the presentation. Finally, to optimize your bandwidth for the best viewing experience, please close any other applications you have running in the background. And with that, I'd like to welcome and introduce Brendan.
Thanks, Eric. Appreciate that. Let me go ahead and get my screen share going here. All right. Thanks for joining, everybody. My name is Brandon Murray. I'm a technical customer success manager at Applitools. I've been with the company for just under 5 years. And prior to that, I was a full stack engineer for just over 20 years. And actually, at the tail end of that, I was a customer of Applitools for about 3.5 years. And, as a customer, basically how I was able to maximize some of that test coverage as a customer is actually what I'm going to show you today and how I did that as a customer. So looking forward to sharing that with you. I do want to just kind of give a summary of my experience as a customer with Applitools. So I was a consultant for a company who was very high on test quality, lots of functional test code, but we were only releasing software every 4th sprint. So we did 2-week sprints. So it was like every 2 months we were delivering software. And I was talking to some of my colleagues about it through the consulting firm that I was working for, because I thought it was silly that we were doing all of this test automation, but at the end of the day, we still had to visually test everything. So that 4th sprint was mostly just manually testing the code. In fact, our manual test plans were basically just following what our functional tests did. So I found out about Applitools, ended up doing a POC. It was a huge success. And after that contract ended, I was looking for work. And now here I am as a technical customer success manager at Applitools. So with that being said, let's go ahead and kick things off. So what I'm showing you is just a simple 1-page example. And if I want to get functional coverage on this, I'd spin up my favorite functional testing platform. As a customer, I was actually using Selenium, but this could be Cypress, Playwright. It really doesn't matter. And what I would do is I'd navigate here, and to get full coverage on this page, I would basically go in and assert all the different elements on the page. So I'd start off with this image up here. I would assert login form, and also this please enter username and password. So I think what the intention of this test is to come in here, click the sign in button, and validate the alert and everything else on the screen. I'd also need to assert the labels here for username and password, the sign in button, the readme, and also just make sure that these Twitter and Facebook icons are there as well. So to do that for this simple example using traditional means, that's actually a lot of code, as you can see here. So for this example, just, basically this is going to take a lot of time to actually create this test. Not only that, but these locators that I'm actually using quickly become outdated, and it creates a lot of maintenance for me. In addition to that, functional tests are often very flaky due to timing issues and things like that. So, if you have an app that's, a couple hundred pages or even a dozen pages, right, there's probably going to be a lot more content on the screen. So you can imagine how out of hand this is really going to get, how quickly it's going to get. So, so not only that, but when I run these tests, so here in this example, my expected UI is on the left, and my actual, with the changes that I've made, is on the right. Even though I've gone through and done all that work, my tests will still uh, allow some of these bugs to escape. So for example, if we start up off at the top here with this broken image, my assertion to check that this image is in the DOM will actually pass, because all we're doing is asserting that that image tag is in the DOM. It doesn't assert that the image has been fully loaded, that we'd get a 200 response back from bringing in the image. It's just simply checking the DOM. And similarly, with the login form text and the please enter username and password text, we're just asserting that that text exists in the DOM. And here you can see that that error message is actually overlapping the login form. But our functional test is going to pass in this case, because again, it's just asserting that those elements exist in the DOM, not necessarily that they're visually correct. And then on this placeholder text change, where we change this to enter your username to please enter name, these are likely just expected changes, but we actually caught this with our automation code, so we'd go in and update it, assuming that was the intended change that we wanted. When it comes to new features, this is another area where maintenance can be a burden, because any new features that come in, I have to be aware of this up front, and I have to add the code beforehand. So here is a new feature that was missed, right? So I didn't have the code in place. And then also down here on the bottom, where we have the Twitter and Facebook icons, assuming those locators change, that actually creates false positives. So we're just kind of assuming here for this example that those locators did change, and that's going to trigger our test to fail. We're going to have to go in and update it, rerun the test. So, so basically this simple example, right? Our code that we wrote using traditional means really doesn't give us a whole lot of coverage, and it creates a lot of noise at the end of the day. So just to summarize, traditional means of functional testing is very time consuming, a lot of time to develop. There's also test flakiness and maintenance. Also, it doesn't cover the UI. One thing that we haven't talked about is, that example that I was just showing you was just one simple browser. So if we have an app that is responsive in nature, we're going to have to execute that multiple times. And a lot of the grid providers out there that people use can be very slow, just by virtue of how they're architected, going over the network and everything like that. So that problem is even further compounded, because now I have to run this across Chrome, Safari, Firefox, if my app's responsive, potentially different environments. So we got a lot of problems in our hands, and yeah, I'm going to go ahead and stop there. And I know we do have some polls that we want to kick off. So Harry, if you can go ahead and kick off those polls, that would be a great time. All right, so the first one, are you running end-to-end tests inside of your pull requests today? And it looks like those results are coming in. It looks like the majority of people aren't. Got 14% that are. That's great. Not seeing any changes. Yeah, so 29% aren't sure. Okay, that's good info. I think we can kick off the next one, Harry. All right. If so, what kind of visual testing solution are you using today? Pixel matching, visual AI, not sure. I'm not seeing any updates to this particular poll for whatever reason. Are you seeing that same thing, Harry?
Yeah, it looks like it's split between yes and no. We're at 47% yes, 44% no, and then 8% not sure.
Okay.
Ready for the last poll?
I'm ready.
All right. Last poll is, if so, what kind of visual testing solution are you using?
Yeah, I think I was ahead on that last one. Sorry about that.
It's all good.
All right, 100% visual AI. Awesome. I'm still seeing 100% visual AI. Is that what you're seeing too, Harry?
Looks like it's gone to 16% pixel
Okay.
matching, 8% visual AI, and 76% not sure.
Okay. Got it. Okay. So good mix there. Great. Awesome. Well, I think we can continue on. Thanks for doing that, Harry. Um, so what I wanted to do next was just share with you a sample of a traditional CI/CD pipeline. Obviously, this is just a sample. There's much more complicated ones out there, but for the purposes of this presentation, just keeping it simple. So, typically, what we see in development, we see a lot of developers, with unit testing, API testing, and things like that. QA, this is often where we see a lot of functional testing. Performance testing, exploratory testing, and even manual testing, and then production. You might have some production monitoring and things like that. So typically in the development phase, when developers are working, they want things to be very fast and efficient, very stable. Typically, unit tests and API tests are, and typically they have these things running in PRs, which is super important because then you get that early feedback. Functional testing, we typically see that run in QA, mostly for the reasons that I mentioned before about the maintenance, time to create the maintenance, also the amount of time it takes to run these tests. We got to run across all these different environments, and then also the limitations necessitate the need to do manual testing. So this is often, these two testing activities are often more of the lengthier ones in the QA pipeline, and that this is also why at the beginning, when we showed that poll a few minutes ago, that's why very few of us are running. One of the reasons why we aren't doing this inside of the development phase, because it takes too long. Putting this in a PR, if you have tests that are flaky, that are taking a long time, developers aren't going to run those tests. And so shifting this type of testing left is very difficult to do. And again, at the end of the day, this is why we typically see this type of testing done in the QA stage. And not only that, but when you think about, if bugs are found, right? So developer commits code, maybe you're testing that every day in QA. You put that out on a QA server, you run all your functional tests, you do all your manual testing. If you find any bugs, because you're finding it past the development stage, these bugs are often a lot more expensive to fix, because now QA has to go back to development and say, hey, here's a bug. Development has to go open a new PR for it. They have to get probably other developers to go in and approve the PR. So it becomes a very expensive process, and delays, decreases velocity and slows down your releases to production. So yeah, that's a huge problem, right? And so if we can address these performance issues, the maintenance and all that stuff, and shifting things to the left, I think everybody could agree that's a good thing, because now we can increase velocity and increase our time to market. So just going to go over we talked about those three problem statements, the time consumption, with the development and maintenance of tests, right? The traditional means, you saw this before, just kind of recapping this, we have 18 lines of code, 21 locators and labels, and 60 minutes to create. With visual testing, that can be addressed with really just one line of code. Now, there are really two approaches that we typically see. One is just visual testing, like with pixel matching, which is very problematic, and I'll explain why here in just a few minutes. And then there's visual testing with AI, which is what Applitools does. And here's the example with Applitools. So what you can see here is I was able to eliminate the majority of my locators. I still need locators to drive my tests. So, clicking on the login button, I still need that. But all the assertions, I can basically replace that with really just one line of code, and that's this eyes check window. To use Applitools Visual AI, basically you need to open a session with us and close it when you're done. Typically, I'll put these like in a before and after. So what you're really left with is really just this one line of code to do that assertion for you. So, and not only, am I reducing the maintenance with locators, but I've also reduced my test time from 60 minutes to 2 minutes. So I'm going to talk a little bit about traditional testing when it comes to test maintenance and flakiness. Again, failures are due to missing or changed locators. I mentioned earlier there are timing issues, right? You're waiting for elements to load before you can assert things. And you have to rerun tests. That becomes a big maintenance headache. And then we also mentioned that's one of the possible solutions is pixel matching, which generates a lot of false positives. And at the end of the day, this is actually why Applitools was created, to basically to address the issues with false positives and pixel matching. So with Applitools Visual AI, so Applitools does not use assertions. We basically, Applitools does not assert using locators. We actually replace those locators, those assertions, with one visual assertion, and so therefore eliminating, failures due to missing or changed locators. When it comes to flakiness, so Applitools Eyes, so the Eyes SDK that you're using to take these screenshots actually has a command where you can actually, it'll scroll the content of the screen before it takes a screenshot to ensure that the lazy loaded elements and things like that are on the page, are loaded on the page. We also have two other products outside of scope for this presentation. But we have our own self-healing execution cloud, which basically, like I said before, you still need to use locators to drive the tests. Using Applitools Eyes, you can eliminate the need for a lot of the assertions, but you still need some. So we have this self-healing execution cloud, which will actually detect when locators fail in your test and will actually auto-heal it for you automatically. Our autonomous platform, which is a really nice, basically it's a combination of natural language processing to drive the test. It also has a record and playback feature. This does not use locators. It actually uses AI to actually, you basically tell it where to go, like, hey, I want you to click on this button. And by describing it, the AI will actually go in and interpret what you mean and actually, click on the element or interact with the different pieces of the page. But again, outside of the scope of this presentation, but in the handouts material, we do have a link to some information on this. So if you're interested, you want to check it out, I highly recommend you do so. But yeah, so all these features address a lot of timing issues that we typically see with traditional functional tests. And then our visual AI mimics the human eye and brain, basically eliminating noise from imperceptible changes. And that's basically, so we're really addressing the false positives that pixel matching produces. So when it comes to coverage gaps with traditional functional testing, here are two really great examples that I like to showcase. One is for Southwest Airlines. So even if I had full functional coverage on this page, my test would actually pass, right? But you can see here that there are clearly some visual defects here. But for the reasons that I mentioned earlier, our tests are gonna pass, and we're gonna basically leak some of these issues into production. And ultimately, this is why we still need to do manual testing if we're not using, or this is why we have to do manual testing with traditional functional testing. And similarly, over here on this Instagram page, it looks like maybe a CSS file was removed, but basically all the content of the page gets located up in the upper left-hand corner. If we're asserting on all this, this would most likely pass, right? And clearly, we don't want to ship something like this to production. So with Visual AI, we actually catch all these bugs, right? Going back to the login example I mentioned earlier, the broken image that we have, we're going to detect that because we're using Visual AI. We're identifying, visual changes that the human eye can see. Here, we're detecting this overlapping text. We're also detecting the placeholder changes. We're also intercepting this new change that just came in, the terms and conditions. So we're able to verify that if we need to. And then if we did have broken locators, we'll never know about it because we're not using them. We don't need locators to check this because we're using Visual AI. So again, we're able to reduce a lot of code, a lot of maintenance, and at the end of the day, now we're able to get full visual coverage on the page, which really eliminates a lot of the need to do manual testing. I'm not going to say it eliminates all of it, because there might be some edge cases where you still need to manually test maybe some third-party services and things like that, but it can really reduce the amount of manual testing that you have to do. I want to touch a little bit on the pixel matching aspect that I brought up earlier. So there are some tools out there that do this. And like I said before, they create a lot of noise, and they do have the ability to adjust the threshold. So you can say like, well, if only 5% of the pixels are different, we'll allow it to pass, right? But where do you really put that limit? Because if you put it too high, right, you're going to allow bugs to slip. And if you put it too low, it's going to be flaky, right? You're going to create a lot of false positives, a lot of noise. And at the end of the day, because of that noise, you're going to be reduced to manually reviewing things, and it's just going to be a waste of time. And that's typically what we see with pixel matching solutions. So, and like I said before, at the end of the day, this is exactly what Applitools was created. On the bottom here, I do have an example using pixel matching. This USA Today example, you notice there's actually some static and dynamic content. Applitools actually has really two primary algorithms that are used. One is called strict, which is really looking for changes that the human eye can see. So up here on this USA Today, even if we were to use strict, this noise would actually go away. Here on this dynamic content, strict would actually fail here, but you can actually change out different algorithms, or you can combine them, which is what I would do in this case, where we can use what's called a layout algorithm. That is mainly used for dynamic content. So obviously with pixel matching, or even with strict dynamic content, we will fail on that. But if we combine that with our layout algorithm, we can get the best of both worlds. But I'll show you another example of that here in just a few minutes. Here's another example that I'd like to showcase when it comes to pixel matching. Lots of different reasons on why pixel matching fails. It could be that the images that were taken for our baseline, which is like the golden image we compare against, that might have been taken on a machine with one GPU versus the current test run, which was taken by another machine with a different GPU. That can create false positives. In this particular case, where we're showing this picture of this puppy, on the left, that was in Chrome 67, and in the right, when we upgraded to Chrome 68, those are the results. And I think, if we look at those changes, you can clearly see that that dog looks the same. It doesn't look any different. But if you use a tool for pixel matching, that's what you're going to end up with. Visual AI, this is what you end up with. So Visual AI is really nice. It's a nice way to reduce that noise that traditional pixel matching means often cause. So when it comes to slow execution time, I do want to touch a little bit on that, and I want to start by just talking about like DOM capture and snapshot comparisons. There are tools out there like Jest that do this, and there are great tools for what they do, right? Where they're trying to capture different states of components or pages and things like that. But what it doesn't do is, when it comes to visual testing, right? this is very fragile because it's really not visual testing. We're just looking at a DOM difference, right? And what I mean by the fact that it's fragile is it tells you that something changed, but if you're looking for something that's, that the user can see, that's where it becomes a little fragile because it's really hard to tell, well, oh, this, how do you know that this particular change, how do you know that's impacting the user if you're not actually showing what the user is actually seeing? So while this type of testing is important, it shouldn't be used for visual testing. And Applitools actually takes a totally different approach. I mentioned that we have visual AI, but the way we generate these screenshots, so what we do, there's two approaches that we have, and it depends on the SDK that you have. So we have our classic mode, where if I fire a test up in Chrome and I take a screenshot, it will take a screenshot directly from Chrome. Similarly, if I take a screenshot from Firefox, it'll take the screenshot directly from Firefox. Well, with our render grid technology, what we do is we actually grab the DOM and the CSS, everything needed to render that page, and we can actually send that information up to the Applitools ultra-fast test cloud. And based on what you've configured, we can actually render that screenshot across multiple browsers and environments. So if I wanted to run it across Chrome, Safari, Firefox, even like an iPhone 15, I can do that. And the beauty of this is I can do that with just one test run. And you can run this, if you have a grid provider you want to use, go ahead and use it, but you can still leverage this technology. What a lot of my customers do is if they're running something like this in Jenkins, they're just going to spin up like Chrome driver and just run it in a headless mode and do all this, grab the DOM and CSS and send it up there. That way, eliminating like the back and forth with all the network traffic. It's a lot more performant. But regardless of how you take that DOM capture, doesn't really matter to us. At the end of the day, we're going to be able to render those screenshots for you in parallel and do it really fast. So here's an actual diagram of this in action. So over here on the left, we got our tests running. Doesn't really matter what SDK you use, but what we'll do is we'll grab the DOM CSS, we'll send that up to our grid, up to the ultra-fast test cloud, I should say. And based on what you've configured, we'll render those screenshots, and then we'll process those images through the visual AI stuff that we've already talked about. So that's how we're able to really address the slowness with traditional functional testing. Is we can do these DOM captures, send that over to our grid, and give you that parallel visual coverage, as opposed to just running these tests, in different doing different functional runs across all these different environments, which is going to take a long time. Because at the end of the day, if we can ship these things left into the developer's hands, things need to be fast. And I do have many customers that are leveraging this within their pull requests today. So I know this does work, and I'm a huge fan of it. So how does visual AI work? I mentioned it before, we operate on this concept of a baseline, which is kind of our golden image that we're comparing to. And here with this Yahoo Finance example, you can see some differences here. We got some dynamic content. And I mentioned before that this is actually using our strict algorithm. And as I mentioned, the visual AI was trained to mimic the human eye and brain and how it analyzes computer screens, and it's been trained on over 2 billion images. And so here we do see some differences, but like I mentioned before, we do have different algorithms that you can mix and match, or we can just change the entire page to apply a different algorithm across the board, which is what I'm going to do right here. And you can see that by using our layout algorithm, this noise up here and right here where these tickers are changing went away right here. But here, where we're actually missing this number, we're able to detect that. So layout is really just looking at things from at least the way I describe it, we're looking at more of the structural content to make sure that everything is still intact, but still allow things to change. So, and again, you can mix and match different algorithms, which is really cool. You can you can do it programmatically, pass in different locators if you want to highlight. One feature that we have coming out is we do have two features actually. Number one, we have the ability to, or will have the ability to detect dynamic text. For example, dates and timestamps, email addresses, phone numbers, things like that. So we can automatically detect that and apply this algorithm for you. The other cool thing that we have coming out, like today, if I have some dynamic content, I can actually go into the UI here and I can actually draw where those regions are, where things are getting annotated, or where things need to be annotated. But what we're adding is the ability to do that with the DOM. So similar to how you would like inspect things with Chrome DevTools, you can actually go in here and like hover over this and apply a layout algorithm to that particular element, which is really handy because it's going to reduce any maintenance that you might have and things like that. So those are some cool features that we have coming out here in the near future. A couple of the features that I wanted to highlight is one of these features is called this hide elements by displaced differences. So what happened here is what I ended up doing is I decreased the top margin or padding on the top of the page, so it shifted everything up. And as you can see, when you make changes like that, maybe you're adjusting the height of the header or something, it's going to shift all the content down or up depending on what you're doing, or even right and to the left. And what you end up with is things like this. And I might have other content changes down there, but this is just too noisy. So what I can do when I have changes like this is I can actually click on this Ignore Displaced Differences button, and that will ignore any of the differences that were caused by the shifting of content and focus only on actual content changes, which you see down here. And if I zoom in, you can see that I got a little fancy with the Y's here. It added too many. So whereas before, all those differences, it would have been really hard to see. So this is really a nice, what I would refer to as like a cleanup mechanism for detecting these types of issues. You can turn this on programmatically, but I don't recommend it because it might suppress issues that you might otherwise like to see. One of my other favorite features is called root cause analysis. So I mentioned before, when we want to grab a screenshot, we actually send up the DOM, and then in our grid, we actually render those screenshots across the different environments that you want based on that DOM. And since we have the DOM and the actual image, what we can actually do is we can interrogate the DOM and tell you what DOM and CSS changes attributed to these differences. So in the area right here where this alert got shifted up, I click on that and you can see that this particular div has a style attribute of top minus 80 pixels, which is really nice to have. So if I'm QA running this is great because now we can actually share this with the developers. If I have a developer running this in the PR, this is a really nice tool to have because those CSS styles can get complicated really quick. So having a tool like this is really nice to have. So just to summarize, right, going over the time-consuming issues with traditional functional testing, development time, maintenance time, flakiness, Visual AI solves all those issues. Same thing with the coverage gaps. For the same reasons why I, as a customer, had to test my functional tests, every 8 weeks or every 6 weeks, and we spent, took it a dozen developers a week testing the UI, right? Visual AI addresses that and can either eliminate or greatly reduce the amount of manual testing that you have to do. It also gets you a massive amount of coverage because now we can actually cover the entire screen. And then slow execution, we got to test multiple browsers and environments. Our DOM capture snapshot with render grid functionality, aka ultrafast test cloud, is a great solution for this. This is one of our most popular products. A lot of people use it and love it, and it's a great way to get to expand that coverage across all those different environments that you need to support. So that's great that we have all this, right? We can apply this to different stages in our pipeline, right? So maybe you have a pre-prod environment where you're running functional tests. you can take those same concepts and run that there. If I want to take this and ship this all the way to developers and take it to the next level, we can do that. And the way we do that is Applitools provides a pull request workflow integration. So we support all the major players, GitHub, GitLab, Bitbucket, all of those. And what this does a couple things for us. Number one, it gives us pull request checks right here to act as a quality gate, and I'll address that here in just a minute. But similar to how we create branches for our PRs and things like that, we do the same thing with Applitools. So we kind of mirror your pull request. So if you're targeting main or master and you create a PR1, we're going to create a PR1 and we're going to be looking at the baseline stored in master. I'm not going to go into the details of how that works because it's rather complicated, but it does work. And actually, as a customer, I have to be one of the first users of this integration. So, but yeah, that's how that works in details outside of the scope of this presentation. But just know it's there, and it's smart enough to keep track of those changes on different branches. Also, when I merge my changes, so all your changes that you accept on your PR, so you're updating these new images, those are going to get automatically merged when you merge your PR. So, and I want to take a step back here for a minute, because if we don't have this, let's say we don't provide branching support, what ends up happening, let's say Harry is another developer that's working with me along some of the same, basically the same application. And if he starts making changes to some baselines, and I'm also making changes, we're going to step on each other's toes, especially if we're using the same baselines. And that's why we branch, similar to like what you do with your source control. So I just wanted to throw that out there. So that's exactly why we do this branching. The third thing that's really cool is we do have this pull request check, which acts as a quality gate. So if I'm not using this integration, and let's say I'm running the test and I get a failure, but as expected, I'm going to go into Applitools and I'm going to actually approve that result, but then I'm going to have to go ahead and rerun my test because I'm failing the pipeline if I get differences. The nice thing about having a pull request check is your pull request acts as the quality gate. So in that same scenario that I just described, when I go in and accept those differences, because I haven't failed my pipeline, and I come here, this will now be green instead of red, and I can simply merge if everything's all good to go. So using this, I can address the issue of having to rerun multiple pipeline checks if I have to go in and approve and things like that. If everything's good to go, I've approved it, no need to run it. I just simply come back here, I got my green check mark, I'm good to go. You'll notice there's actually two checked here. One is for the tests themselves, the actual differences that you'd see on the screen. The second one is an SCM check that just detects if there's any baseline conflicts. So, if me and Harry are working off the same set of baselines and he merges his changes in before me, it's going to result in a conflict because I'm trying to update a baseline that he's updated. And really the solution to that is just to rebase or merge master and main into my branch, rerun the test, and I should be good to go. And again, this is just if you want to shift left. Like I said, a lot of what I'm showing you besides this is can be applied to any stage within your pipeline. So circling back on that graph that I was showing earlier with the sample CICD pipeline, assuming we're using our source control integration here, what I'm able to do is add Visual AI functional testing to my development phase. So now that I've addressed all those issues up front with maintenance, the speed of the tests, right? Now that I can run things fast enough and more stable, I can actually do that within my pull request. So adding Visual AI functional testing to my pull request eliminates the need for me to have to do this in QA. Obviously, if you guys have things in QA and staging, pre-prod, and you still want to use this, totally fine. It makes perfect sense. We got performance and exploratory testing, and we're able to either eliminate or greatly reduce the amount of manual testing. And now we're able to get that feedback loop into our PRs, which is going to help us increase our velocity, number one, and it's also going to basically help us release our software much faster, because this bottleneck that we had right here between the functional testing and QA has now been moved over into our PRs, and we're able to get that immediate feedback. And I will tell you, as a developer who has actually worked with this, having this in your PR and knowing that you're getting this visual coverage across all the different environments that you need to test is a huge win. It gives you a lot of confidence, knowing that you're committing this code, and you have full visual coverage is a huge win. And yeah, it's pretty awesome. So, and that's all I had for today. I guess we'll go ahead and kick off the questions and answers portion of this webinar.
All right. Thank you, Brandon, for your presentation. We had a few questions that came in from the attendees. Again, feel free to post your questions in the Q&A panel, and we'll get to as many with time permitting. For those questions we don't get to, our team will be reaching out with answers through email. All right. And our first question is from Janice, who asks, what's the flow of auto healing in visual AI? Does the test fail once the locator changes, or does the auto healing happen during the test case and fixes it without the need to rerun the test?
Great question. So it's the latter. So if we do detect a failure, so the first thing is the first time we run a test using our self-healing cloud, it's going to learn and understand the tests, right? And then the next time we come in, if one of those selectors change, what we will actually do is we'll detect that, and we will basically replace it with a suitable selector. And then in Applitools, we have to actually propagate that change to you. So if you want to use that change, you can. You could just leave things as is and keep going on. Really up to you. But those changes will be broadcasted in the UI, and you'll be able to see it and update your code. Or not, you can still continue. That's the beauty of that solution. All right, next question.
Next question is from Srini, who asks, these Applitools needs to be plugged into the existing framework, or these tools will replace whole framework and provide E2E automation solution?
Great question. So if you're just using our SDKs, we are just basically a plug-in into that whatever your framework you're using. So if you're using Selenium, Cypress, we just bolt right onto that, and you just install our SDK, and then in your code where you got all your assertions, you can yank those out and basically just replace us with that visual assertion that you need. That's if you're using our SDKs. Our new autonomous platform, which I didn't really cover here, it's out of scope. That is actually a solution that using visual AI can actually replace the functional framework that you have. So it's going to use natural language processing. It even has a record and playback thing, which basically do all that for you. And so that's great for folks that are maybe not as technical, maybe you have some business analysts, or maybe you just have people that don't want to write any more code. So that's a good solution for that. So so I think I answered that question there. So
All right.
yeah, go ahead. Next one, Terry.
Yep. Next one is from Philip, who asks, can you give examples of the differences in observed slow execution time?
Can you be more specific? Are you just like the differences with, I believe, basically ultra-fast grid versus the traditional means? I don't have the exact stat, and I could get back to you, but I think we were seeing like an 8x improvement using ultra-fast grid versus other means. But don't quote me on that. We can follow up with a better or a more precise number for you.
All right, then we got another question from Philip said, yes, ultra fast grid versus traditional.
Yeah, we'll follow up with that. I'm pretty sure it's like an 8x speed improvement. I'm not sure what the latest stat is on that.
Okay.
But we'll follow up with that.
Sounds good. Carla asks, do I still need visual AI testing if I use a CSS framework like Tailwind?
Yes, you do. So yeah, Tailwind is great for, great CSS framework for, applying styles and things like that. The example I like to use is, let's say I go in and I make a change to, maybe I only want to target my mobile devices, and maybe I enter the wrong thing, right? Having visual AI is going to show me that, right? If I don't, that doesn't get detected in the code review, I'm going to produce a bug. Also, Tailwind can have bugs too, right? So, but maybe the way you're using it, the styles don't jive. You could introduce bugs. Also, when Tailwind comes out with the new release, well, how do you know those changes aren't going to break what you have, right? So absolutely, this is exactly why Applitools is needed for things like this, not just doing your own CSS, but also using third-party libraries as well.
All right, next question is from Jaya, who asks, how does visual AI integrate with existing test automation frameworks like Selenium or Cypress?
Yeah. So as I was mentioning earlier, what you would do is so for Selenium or Cypress, we have our own SDKs for both of those. In fact, I think we have upwards around like 50 SDKs. So we support all the major players: Playwright, Cypress. We have integration with Storybooks, Selenium, JavaScript Selenium, Java Selenium, all of them. So what you would do, so for example, if I wanted to hook it up to Java Selenium, I'd go and update my POM file to include the eyes Selenium framework, bring that in, do a Maven build, and then I can go in and do those. In fact, that example that I showed you earlier, the example I showed you earlier was a Java example. You just import the eyes, imports at the top, and go in and do your eyes open, eyes closed, and then in between there you do your eyes check window, and you'd see something very similar for Playwright and Cypress. So yeah, it should be pretty easy to get that stuff up and running. There is a tutorials link that we can provide after too, which will basically take you to some tutorials on how to get started, either with a brand new framework, assuming you don't have that framework set up, or you have an existing project you want to integrate it with. We have some really nice tutorials that will help you do that.
Awesome. All right, next question is from Srini again. She asks, can your tools / SDK support multi-browser and parallel test execution?
So we don't actually. So what you would do is, we're not actually, at least when I'm talking about the eyes SDK, we will leverage the driver that you provide. So if you are spinning up things like Chrome or Firefox, we will leverage that. But what we will do is we will take the DOM capture and we will actually send that up to Applitools and rather render those screenshots for you across those different environments. Our autonomous platform actually works the same way. It actually uses the our own execution cloud to execute the tests. I don't know what it's exactly using. I think it's Chrome for the actual driver, but it does the same thing with the visual renderings. It will basically take that DOM capture and render that across the different environments.
All right, and then the next question we have is from Lee, who asks, can I drop all my insertions?
It depends. So assertions can be good in some cases. So when it comes to the assertions I was showing you before, absolutely. But where assertions can be really helpful is, it can address some timing issues. If you'll see, and we can address that as well. But if like a certain part of the page is like super slow, you can maybe add an assertion to help wait on that. Normally, just our lazy load option will actually help with that. But the other case where I do recommend you use it is anytime you have like some dynamic inputs and maybe you're validating some business logic, right? That's where I would still use those assertions. So maybe you have some inputs and you need to go and verify that, a certain number is, maybe you're doing some math or you're adding something up and those inputs are dynamic. Absolutely, you'd want to use assertions to make sure that business logic matches up. Because Applitools can add visual AI, and if that changes, yes, we can tell you that changes and everything's intact. But if you want to actually look for specifics and actually validate the business logic, that's where I would use assertions combined with visual AI.
Next question is from Srini, who asks, do we need to refactor the existing Selenium code, POM, after we integrate with Applitools, or the existing code base is still good?
Existing code base should be just fine. Now, I do recommend that you at some point refactor it because those same issues with locators changing and things like that are still going to happen. Um, but if you want to get started right away, you just want to add it. Maybe you have a good locator strategy and you just want to leave it. That's totally fine. Applitools doesn't care, but I don't really see a need for it to be there. But if you want to leave it, really up to you. But just note that those risks of locators changing will still be there.
And we've got a question from Jason who asks, how does Applitools know what golden image to compare against?
Excellent question. So Applitools operates on what is called a baseline, and that's that golden image that we're talking about. Um, and there's 5 properties, at least with web testing, um, that make up a baseline. That's the application and test name. The application name is usually pretty static throughout the whole thing, but it's gonna be your test name, viewport, right? Because if I have a viewport, maybe I'm running a page in like 800 by 600, which is like a tablet viewport. When I have something in like a mobile viewport, even if I could scale the images, the layout would likely be different, right? So that's the reason why a viewport is part of that. Also, browsers are going to render things differently. Chrome versus Firefox are going to render differently. And then the OS. So browser, viewport OS, application name, and test name, all those make up a baseline or golden image. So that's how we know what to compare against.
All right, we got a question from Philip who asks, do you have any additional support for big package software such as SAP, Workday, Salesforce, etc.?
That's a good question. That I'm not sure. That one I will need to get back to you on. So yeah, let me get back to you on that. I'm not sure. I think I have the answer, but I just want to make I'm sure I'm correct. I believe we have some things available for this. But yeah, we'll follow up separately with this. I think we had another question earlier as well that we need to follow up on.
Awesome. Well, unfortunately, it looks like we're out of questions, but I would like to thank the attendees for participating today in the Q&A. Before we go, I'd like to hand it over to Brandon for any closing comments for our viewers.
Yeah, just wanted to thank everybody for attending. Really appreciate your time, and also appreciate the questions at the end. So thanks so much for attending and for your participation.
Well, on behalf of TechWell, I'd like to thank Brandon Murray for his time and insights on maximizing test coverage, and our sponsor, Applitools. A special thank you goes out to our audience for joining us, and we hope to see you at a future event. Take care, everyone.